All right, are we ready to get started?
Yeah!
Yes, I like that energy. I like that energy. Well, I'm super excited to talk to you guys today. If you've been waiting for someone to say some blasphemous stuff, it's going to be right now. I'm really glad Dave Nugent got me to come talk to you guys today. My name is Steve Newcomb. I work for a very small company called Famous. And for the better part of the last 2 years, we've been working on one specific thing in HTML5 web app, and that is performance. We had this very fortunate opportunity. We were given $1 million to just sit there for 2 years and really understand performance deeply. And we actually popped our heads up for the very first time a few weeks ago to show a showcase demo to sort of kind of give people an idea of what we've learned during that extremely painful process. And the idea that we wanted to go through today is to sort of show you that demo and then actually walk you through exactly what we had to learn to get to that point and all the lessons we learned along the way, so that as you guys are building your mobile web apps, maybe we can help you like skip a few steps along the way. How many people here have built at least a sort of Hello World mobile app on a mobile product? Okay, how many people have taken it up to maybe a level of a sophisticated prototype? Okay, how many have built full-blown consumer mobile app that you launched? Okay, more than you thought, Andrew. Awesome. So this is good. So how many people here have started to experience performance issues with web apps of all sorts? Right. So for me, like, you know, when you're talking to other JavaScript engineers and you hear the same story over and over, that people are batting their heads up against a myriad of problems in performance. And so what we really try to do is abstract away from that and try to get to the root of the problem so that we can make engineering easier for performance. And what I'm going to do first is just show you the demo, the performance stress test demo, and then I'm going to get into the hows and whys of it. So what we have here is, this is a stock iPad 3 running stock Safari. It's iOS 6. What you're about to see is not WebGL. It is not using Canvas in any way, shape, or form. And if you are familiar with then animations, you should know that the only thing left is CSS3 primitive transitions. But I'll even say there the answer is not exactly. So first of all, we showed this demo. I'm going to actually speed it up for time purposes here. So what we wanted to do was build a particular demo that stress tests a lot of different things that are normal problems. What you're looking at here is actual DOM elements. Each of these DOM elements is a div, and they are styled the way that you style normal DOM elements. You'll see that each one has varying degrees of opacity, and the dreaded WebKit box shadow is on each and every one of these, and the text inside of these divs is actual real text. How many people here have tried to build infinite scroll view? How many people here have really dealt with all the performance issues with it? Probably everyone who's ever tried to build one. What we wanted to showcase first is just, we wanted to understand if we could have all these objects in space, some of them randomly moving around, and all these things that are typical things that would normally destroy performance, could we get infinite scroll view? So we're playing around with infinite scroll view at a sort of a very fun level here in all full 3 dimensions. And so this was one big area that we worked on. And then another big area that we worked on is to be able to change the view and the control dynamically at the same time, and to do that while interrupting an animation in mid-flow. And that's very, very difficult to do. And so if I'm going like this, and I decide to change the plane in real time, that's very, very hard to do that sort of stuff. And what's even more is, as I change this plane, and say I go a little bit Star Wars on this, up and down doesn't mean up and down anymore. It's actually transforming into the transform itself. If I go like this, left and right no longer means normal left and right. We also wanted to mess around with changing entire world views and world containers and controllers without getting a blip. So we can actually change between different shapes here to a periodic table, to a sphere, back to this thing that we call paraflow. And in each case, we can actually start playing around with it as the object is even constructing itself. We can even deconstruct the object and actually make a very weird looking object here. And then traversing to objects in this code is no more difficult than saying, go to the right place. Being able to change the control and view as you change in different locations. So here in the sphere, I'm spinning around doing one gesture. I go inside the globe. Let me come back a little bit here. And I'm doing the same exact gesture, but the way it's controlling it is actually completely different. And so I love showing this particular demo to people who are native ideologues and think that native is the only way to do things, and that native is the only way you can get to performance like this. And I love their reaction, because they're like, what is going on here? And this is when we start having fun with them. Because they're saying, wait a minute, that was running on an iPad 3. Surely that doesn't run on an iPad 2. And the answer is yes, it does. Surely it doesn't run on an iPad 1. Yes, it does. And I'm going to get into like all the things that we learned to get along the way. Now that interface that I showed is a completely non-realistic interface. That's not an interface of any app anybody would build. But again, we wanted to stress test it just to show all the different things we can do. So this is the story of Famous. When we started, we were actually a consumer app identity company. We had this cool idea that was going to be the next killer wave app, and we wanted to build that app out. And the thing is, it had a very ambitious user interface. We decided to build it in HTML5 because we liked that sort of stuff. It had to work on lots of devices, iPad 1, 2, 3. It had to work on phones, tablets, PCs, and game consoles. It had to work on iOS, Android as both a web app and within a wrapper. And then it had to work on lots of different inputs, including touch, keyboard, mouse, and even open air gesturing systems. This is the Leap motion device. I don't know if has anyone ever seen Leap? Does anybody else have one? I don't think so. We were the first company to ever get one. So we've been playing around with stuff like this, and this is the type of like interface that we wanted to build with this consumer app. So we had very aggressive goals. And in that process, we thought we really knew what we were doing when we started, and we had some great engineers, but we actually didn't. And along the way, we probably hit every performance issue that you could probably ever hit because of the grand scope of our product app idea. We battled through a lot of false promises. I can't tell you how many times I read an article online or went and heard someone speak where I was like, that's it, now we've got our problem solved. And then we go back to coding and we're like, nope, it isn't. We went through a lot of frustrating experiences. We learned a lot of things. We're going to share our journey with you today. So the way I've sort of tried to divide up the talk is making larger points so that we sort of abstract out to the big problems. And then where it makes sense to go deep and actually look at some code or actually talk about deeper things, we're going to go deep. Our first big realization is that we at first loved CSS3. It could do all these cool things. We loved playing with transforms and transitions and all the cool stuff. And then we began to hate it. And there's a couple of reasons for this. There are things that are in CSS3 that are really the domain of an engineer. There are some extremely powerful ways to talk to the GPU or to do things that could really either affect performance in a negative or positive way. And so we started realizing that someone we felt, mixed an abstraction somewhere along the way. Suddenly, this place where designers would normally style things and color them and make them look a specific way could go in there and screw your world sideways by putting a 60-pixel box shadow on something, and they wouldn't know any better, and you'd want to kill them at the end of the day. We had situations where this 1 second from the bottom WebKit transition, all 1 second ease out, was put on an inappropriate DOM element because this junior developer we were looking at didn't know any better, and he thought, I wonder what that does. So he tried it, And next thing you know, Dan in the audience and I were sitting in there for 5 days trying to sleuth what had happened. And so you get into these situations where these can cause problems. And so that's a very awkward spot to be in. And there are no really good debug tools to go figure out when you're doing something that's causing a system-wide performance problem. It causes a lot of discomfort between designers and engineers, and it had a dramatic impact. We had to catalog all these quirks, which was a confusing task for us. We had to refactor all of our CSS. That totally sucked. And then we had to, and I'm going to concentrate on this one a lot today. We had to audit our third-party libraries that touch CSS to make sure that none of our war chest of all of these things we had amassed over our careers, where we're like, these are our tool chests that we bring to bear when we build anything. And we've all amassed these over our careers. We had to look at all of these to make sure that it wasn't doing something funky with CSS that was actually causing the performance problems. And so instead of actually going in and giving you, like, sprinkling with you a few examples of these things, when we actually post this presentation online, we're going to actually give you a whole library of links so that you can read up on articles and read up on things, and we'll, like, fast forward you through all the process that we went through to get to these realizations. Our second realization, learning code for computers has masked bad coding habits. And what we mean by this is that we all learned how to code on the computer first, and then we went to mobile second. And what the proper way to code is to learn how to code on the weakest device first, and then grow upward into the strongest devices. So we actually found out that we had to relearn all of these things: proper DOM manipulation, proper event handling, proper data handling, proper image handling. And what we realized, it was how all these things act in concert that actually allow you to arrive at a base level understanding of what performance really is. The impacts of this. We had to learn all these new performance optimization methods. Lots of people are talking about these, reflow, the whole sector of reflow and so forth. These are actually super fun things to learn, and right in the area of, like, learn them. They're lots of fun. Refactoring all our code to make sure all of this stuff was working. Man, we had to do it. But again, I'm going to concentrate on this one. Then we had to go back and look at our libraries. All of our favorite libraries were like, fuck, they're not doing stuff properly. And we began to look at these and say, this is starting to be a real problem. We started getting worried about this war chest that we loved. Again, we're going to have links for this. Safari and Chrome are not created equally. Big whoop, everybody knows that. But you have to catalog these things. You have to refactor your code to make sure that you're taking these things into account. And you have to, again, audit third-party libraries to make sure that they're not doing anything weird too. Again, I'll have links for that. A lot of HTML5 components don't work, or don't work like you'd expect. We've heard a lot about that. And there's things like cache manifests and so forth. Again, you have to catalog all these things, remove the ones that don't work, don't use them, and again, make sure none of your third parties are trying to use them either, because they'll mess you up. At the end of all this, we realized, and I will always remember this day, where we're like, we cannot use any of our old libraries. We got rid of them all. We don't use a single third-party library when we're trying to go after performance. So all these things, if you use jQuery animations on a computer, if you use a lot of jQuery plugins, if you use jQuery itself, if you use things like my favorite library, my favorite fun library was Isotope. I don't know, does anybody here use Isotope? I love that library. It's so cool. It's so fun. Unusable. And so we actually had to go back and say, crap, we need to actually almost rebuild our entire war chest that we used to bring to the table. So we had to catalog which ones didn't work, remove them, and rewrite them. Once we had this sort of base, now we knew how to manipulate DOM, we knew how to handle events, we knew how to do data, we knew how to do images. We're like, okay, we're now actually beginning to learn our instrument and feel comfortable in our space. But that was nowhere near enough to even get to performance yet. Next, we started trying all the exotic DOM manipulation techniques. And you've seen these. A lot of people are talking about them. DOM object reuse, the 3 panels method, the event horizon method. There's a list of about 70 long here, and we're going to provide links for that as well. Learn all of them. They are necessary. If you don't know them, you have to learn them, or you won't have performant apps. Learning some exotic frame rate and GPU techniques. Eventually, if you build a sophisticated enough web app, you will get into request animation frame and understanding it in great detail. We even got into understanding how to do frame rate throttling, and we even built a method to build multi-threaded JavaScript. Basically, we went off the deep end. And what you realize once you get into GPU is that there's really no way to get a look inside the GPU to see what's going on, and that's very difficult. Now, a lot of the browser companies are building new tool sets for us to look inside and peer in there to know what's going on, because you want to hardware accelerate everything you can, but you want to manage that wisely. But right now, you can't actually look at the buffer size or resource limits or object counts inside the GPU. And that means you're kind of operating a little bit blind when you're operating with the GPU, and you can make the device blow up. And so that's very, very hard and tricky and an esoteric thing to really learn how to do. Again, we'll have links for this. About a year after we started, we had finally got to the point where we started feeling like we could build pretty much anything we wanted and do it performantly. And I'm going to show you a demo of where we were at that time. So what we're looking at here is a stock iPad 2 running iOS 5. And this was actually a look at one of our first apps. This is using a design metaphor called cards. It's something that you've probably seen in a lot of iOS apps. And I'm just going to give you an example of the level of performance that we were getting out of this. So I'm clicking faster and faster. We built ScrollViews that don't have any flicker or jitter at all. We were able to play, well, the internet's not really fast enough here, but high-def movies we can play without having any effect on the scrolling. We were able to do things, I don't know if you can actually see it here, but we're doing peek-in techniques where you see all the comments and the pictures are actually settling into place as it comes in. You're seeing the picture Ken Burns over here. We have custom media viewer libraries set. You're seeing something that's really hard to do here, and the scroll view is an offset paginated scroll view with the comments up there. And we did this, believe it or not, with Isotope. For all the Isotope lovers out there, there it is, nice and sexy. And jQuery mobile scroll view, believe it or not. And this was painful. The lesson we learned coming out of this exercise of building this app was that everyone we showed this app to was like, oh my God, you guys are brilliant. This is going to take off. You can now build your product idea, and it's going to take over the world because you have solved performance. And the reality of it is that everyone loved what they saw but us, because we knew what was under the covers. And the reality was that we actually didn't feel good about what we had built. We felt like every dodo bird that looked at this and didn't know what questions to ask, we could fool them into thinking that this was elegantly built and well engineered. But under the hood, we knew it was a gigantic hairball. And so we arrived at what I think is a really, really, really important message. If you try hard enough and you work long enough, you can make anything that you're trying to do in HTML5, just about anything, performant. So those who say HTML5 cannot be performant are flat out wrong. What's the actual issue is the level of effort it takes to get there. And the app I just showed you that we call Nathan, I can tell you the level of effort it took to get to that level of performance in that app was ridiculous. It was so ridiculous that me as the CEO, I was sitting there thinking, you know what, guys, as much as we love JavaScript and as much as we love HTML5 stuff, it would actually just be easier and faster and more scalable to build all the things in their own native languages on each device. It just would be. And we were in this area where we weren't enjoying coding anymore because it wasn't actual engineering. It was dealing with basically the jankness of how WebKit renders. And that made engineering not as fun as we wanted it to be. And so the best way I can describe this is that performance, when you get into the sophisticated layers of building something complex, what you realize is it's not a function of a discrete thing that you did or didn't do. It's a system of interaction between all the things that you're doing. And as your code base grows, those number of interactions grows. And then as your number of interactions grow, every time you have a performance issue, a slight jitter, a flicker that occurs somewhere, it becomes increasingly more difficult to hunt that bug down and solve it. And so the primary difference between coding in native and coding in an HTML5 is that when you have a bug in native, you hunt it down and you fix it, and it's done. But because WebKit is not there yet, what happens invariably in HTML5 is you end up having to dance around a bug you can't fix. And so the native app, the Nathan app that you just saw me give you, was basically an exotic dance of a lot of bugs happening, and we were hiding them. That's basically what goes on when you're trying to get performance in today's current HTML5 infrastructure. And at the end of the day, we just didn't enjoy that. We wanted something that was rock solid, elegantly built, and we were proud of. And so we actually said, well, these people gave us all this money, and we got to build something. And we're not comfortable using HTML5 to do this as it stood. So we're like, well, maybe we'll just build the whole damn thing in WebGL or Canvas. But the problem with that is that we lose all the things that we love about the web. We lose event handling at the object level. We lose text and CSS effects, buttons and forms, all the things that are great about webbiness. And so we wanted, the best way to describe what we wanted was WebGL with all the benefits of HTML. And so we abstracted our way out of this and said, what is the sort of higher level order thing that we're seeing here? And so we said, use the right tool for the right job. WebGL is great for 3D rendered games and things like that. Canvas is great for 2D rendered games and things like that. The browser is great at rendering documents. It's not great at rendering apps. And so we said, why isn't there a renderer for apps? And we said if we solve this root problem, then we begin solving all the hairballness. So let's dig now a little bit deeper. So now I'm going to actually start to get specific and technical quickly here. This is WebCore. It sits in the side of, it's basically the core part of WebKit. And this is a highly simplified look at it, but there's basically parsing, DOM tree construction, render tree construction, layout of the render tree, and then render tree painting. And we took a long time and sort of looked at this and said, where do the inefficiencies exist? And is there an abstraction that we could pull away from this that makes coding HTML5 apps an order of magnitude more simple to do and maintain performance? That was the issue. Here are the problem areas. It's really the code that takes the DOM tree and the render tree, and then ends up creating what's called a matrix 3D transform and passes that on to the GPU. That process of ending up at a matrix 3D transform is inefficient and slow, primarily because the browser currently, this code that was written eons ago, was built to render a document. So we were like, wow, let's do something crazy. Let's build our own renderer in JavaScript. JavaScript is getting to be really, really fast these days. And we said, I think if we had our dream, we would add this to WebKit. But I'm not going to wait 2 years for WebKit to do this. And we said, why don't we build this in JavaScript and actually show the standards body which direction they should go? But let's give ourselves an option to have a solution now. And so we took a bet that if we built a render engine, controlled it with a physics engine, and then built a rules framework to deal with all the differentials between devices and browsers, that this is sort of our dream scenario. And so we actually went to work building that. And so this is kind of the way we see it. At the end of the day, we don't it's not that we're saying we don't use WebKit. We're kind of like hamburger helper to WebKit. And we make WebKit able to render apps efficiently. And at the same time, we hope we're showing the standards body sort of the path forward. I'm looking at the time here. I want to get to the demos. So you'll see that these are the modules in here in the system. And this, if you've ever done WebGL stuff, you'll say, oh my God, that looks like all the stuff you do in WebGL. But the output of our engine is HTML and matrix transforms. And that's what makes it special, because you get all the goodness of webbiness with it. But how do we do it? How do we actually do it? What we do is we simply said the CSS3 transition primitives shouldn't be there. And we don't use them. So any CSS3 transition we don't use, and we don't allow WebKit to compute the transform. So I'm going to let that absorb that, because that's the whole ball game right there if you get that piece. So it's kind of brazen to say that JavaScript could compute this faster than C, right? But there's no limits to how poorly you can write C code, right? And certainly if you wrote the C code correctly, it would be faster than JavaScript, perhaps. But we postulated that this code that's old and meant to render documents, if we built new code that was meant to render apps, it would be much more efficient. And so what we're effectively doing is we're skipping those inefficient parts that exist inside of WebKit. And what this results in is two things: much more performance, but perhaps even more importantly than that is stability. One of the biggest problems that you guys have probably experienced is frame rates that go like this. They're all over the place, and you don't even exactly know why or could predict when they're going up and down. There's lots of theories on this. In this method, we can actually throttle and control frame rate. And so where performance and frame rate management used to be in the world where like you would have a business person come up to you and ask, can you build this app performantly in HTML5? And you have to be like, I don't know. I have no idea. It's too complex to answer until we actually try it. Now it becomes a function of just knowing what GPU is on that device and what CPU is on that device. Because we use the CPU to calc the transform and the GPU to render the transform. And so if you know those two things, you can get to a point where you can somewhat accurately predict what the performance is going to be. So now, when we go back to looking at this, and we understand this as a surface rendering machine that's rendering surfaces. This is rendering about 110 different surfaces at any given time in the viewport. And then we look at the performance here of this, and we think WebGL, while we're looking at this performance, we think, well, that makes sense. But the big difference between us and WebGL is WebGL is meant to handle millions of surfaces. Our engine cannot handle millions of surfaces. It can handle hundreds of surfaces. But when you look at an app, what app has more than 20 given surfaces at any time? If you even look at the Facebook app, the one that has a lot of controversy around it because Facebook pulled out of HTML5 to a large degree, for a short period of time, hopefully, that only has 4 surfaces. So something like the Facebook app or the Twitter app or the Spotify app or Flipboard or any of these apps that you think about in the iOS world that are currently right now would be very, very, very difficult to do scalably and easily in HTML5, now become trivial. And so let's go back here for a second. Looking at the time, okay. So then the physics engine, let's talk about the physics engine. We built a physics engine for 2 reasons. One is that, how many people here have built a ScrollView from scratch? From utter scratch, all right, I like it. So one of the things that you know when you get a designer talking to you about the ScrollView is they say it doesn't feel right. It needs to, there's some sort of uncanny valley weirdness that's going on, especially if you run the same damn code in Android and then run it on iOS, and then one of them feels real jank, you know, and so you're like, you're getting into this territory, and then the designer says something that, you know, makes you want to punch them in the head when they're like, I want to bounce at the end of it. And you're like, all right, you know, and then like, I want it to bounce 3 times. And you're like, 3 times, really? Okay, 3 times. And what you end up doing is custom coding it, right? That was also something that we were sick of doing, and we didn't want that weird interaction between the designer. We wanted the designer to be free to design anything in their head without the engineer having to recode anything. So the proper abstraction to do that would be to build a physics engine that has kinematic actors that can act upon any component. And then you just let the designer play with the kinematic actors as much as they want to get the look and the feel that they want. So I'm going to save time and go right to the demo here. Okay. Oh, don't make me hit refresh. Please, internet.
You can use it direct. There should be
We got it. The beauty of all this, the periodic table demo that you saw, 45 KB. The scroll view example I'm about to show you, half a kilobyte. So we'll talk about that in a minute too. So here's an example of a scroll view. And how many times have you given your scroll view to a designer and they're like, this isn't quite right? I want it to bounce at the end. So this right now is the default, exactly default Apple. How do you add a little bounce to it? Well, and then on the right-hand side, what we put up is all the kinematic factors that are acting upon here. And so this is kind of cool. We can just move the edge dampness down, and we have a nice little bounce. We can even create a clock for ourselves if we want. And so the idea here is now the engineers can actually build tools for the designers to play with. And you can say, look, if you want me to model a turd on this scroll view, I can model a bird turd on there. We've actually even modeled syrup on there. This gets into a fascinating field because now with a kinematics engine, you can model universal design principles inside your scroll views in ways that you never could before. Imagine that you're going through a news feed, and some stories in your news feed are more important than others, maybe as a result of tweets associated with it or Facebook likes or something like that. You can actually apply different mass to each of the stories. So as the users are scrolling through it, you could slow down or speed up, or if you added a paginated scroll view in there, it would actually paginate differently depending on the mass of the objects in there. And what happens when you give this to a designer is they freak out, and they're like, this is awesome, and they begin playing. And these are only, I don't know how many there is, however many kinematic actors there are, there's only that many there, but you can do infinite. And this is a lot more fun to code as an engineer, because you're like, coding a bird turd is a lot of fun. Coding a bump in the road is a lot of fun. And this is just a scroll view. Imagine coding this on any component that you could imagine. Now, the second reason we built this physics engine is because we saw Apple sue Samsung for like $1 gajillion because of what's called the rubber band patent, which makes every designer who's doing a scroll view say, well, crap, I can't do a scroll view. Let me knock this back up to normal. So now you can build scroll views without sort of being worried that you're in the targets of Apple where they're going to be like, psh, you die for building a scroll view. So that was the second reason we built it. But there's lots of super cool things. Say you have a paginated scroll view, and again, now you want to add bounce to it. So I remember it's page damp. So now you have your bounce. There we go. So what does the code look like for this? This is all you need to do to instantiate a scroll view. We really, really, really worked on making this very elegant at two levels. One, if you're just a coder that you want to compile stuff together and get shit done, you can just go to work and get stuff done. But we also let you go right down into the source code of it as well. But let me continue through here. So this is now where you're controlling the offset height, or sort of the height of the scroll view. Tight boundaries. So this is now changing edge firmness. So this feels, I know you can't feel this, but I can. But this is basically a much tighter scroll view. It feels very different than Apple. Extra bounce. This is the bounce I showed you. This is what the code looks like behind it. So it's just literally an attribute that you're adding. Syrup mode. So here's the syrup we modeled. We call this syrup, but what you're actually doing is just changing the edge damp. And then we showed you infinite bounce as well. You can also set arbitrary points in here for page views. Remember I showed you in the Nathan demo the offset paginated page view where it starts off a little bit of kilter, and that's commonly done to let people know, hey, this is a scroll view where there's more content off to the right. And in any other given scroll view, you have a UI scroll view or a scroll view, and you have a scroll view clip, and those are the only two things you can play with. In the famous scroll view, you can play with boundaries in many, many, many different ways and arbitrarily set where you want the pages to be, and you can even have them associated with different things to make pages change in size as you go along. Beginning without an end, very easy to do. Whoops, where am I? Infinite scroll view, meaning there's no ends anywhere. applying 3D. So this is, Mark, is this including the Surface Engine now?
Not quite.
Okay, not quite. So let's say you wanted to be able to have a normal scroll view here, but you also wanted people to be able to tilt in 3D space inside of that. You're getting into areas where it's super duper simple to do what used to be incredibly complex things. So now you're at a grand total of what, 16 lines of code? And just to show you for fun things, you can do things like, one of the big things I want to do is what's called paginated roulette. Dan remembers this, but you haven't ever seen it. So the idea was things are paginated scroll view, like this presentation. Oh, there's that still going. But what if I'm looking through news stories and I know that the story I want to look at is way at the end of that paginated scroll view? Right now I have to go, What if you could actually measure force as a physical affordance? And I can just wing through it. So right there, what we're treating the pages as is the kinematic affordance we have there is a magnet on each page. And you can assign strengths of that magnet, and you can actually break the magnet as you go. And this is just the beginning of what, I think that the limits on what someone could create here is really endless, and we're just showing some beginning examples of this. Oh, demo there, we did that. Then the last thing we did is built our framework to basically handle all the input mechanisms. We want you to be able to build that scroll view and then work on the leap motion device in space without having to know to code to the leap. We want that automatically handled. And then you get your control features. Again, in physics, you get kinematic actors that you can apply to gesture systems, touch systems, mouse, and keyboard. And so that's super cool as well. Oh, and the last demo. All right, I'm going rogue. All right. This is a simple infinite scroll view, half kilobyte of code. We're loading infinite DOM here. We're doing animations in between as I'm doing this. And Mark, can you come up here and hold this because I need to do the other thing?
Yes.
No, we're good. Just hold it. All right, here we go. So I'm scrolling here, and I'm actually planing in 3D so it's doing a crossfade transform here with all this going on. Now, what's important about this demo? It's an iPad 1 running iOS 3. So when you get down to really, really, really manipulating the GPU, you can absolutely get to the point where you can give native the gigantic middle finger and say, we can do this. And so that's what's really important for us is that we saw this and we're like, all right, finally, we have now this framework, we have a physics engine, we have a rendering engine, we need a plug, and we had this great framework now. And we began coding, and we are very, very, very excited because now we're back into the world where it's elegant, it's cool. But then we had a problem. We were coding along, and we're like, what was the product we were building again? And we're like, I think it was Pinterest for blind people or something like that. And we're like, what was it? And we got to the point where we were like, you know what? I think our framework is more important to us than our product idea was. That was a fun day when we went back to our investors. And I got an earful for that one. But I think our investors are now behind us because they realize how big a deal this is and how important it just is for the JavaScript community to have sort of a new tool that says, all right, now we can get performance and it can be easier for us. And what we realized in our company is that's really what we're passionate about, is enabling all the people here who have been battling and banging their heads up against the wall. We're like, wait a minute, how cool would it be if everyone could use this and everyone started benefiting from this, and all this cool stuff would be starting to be built that we can't even imagine today. And we're like, I'm much more pumped about that than the Pinterest with about.me flair in it. And we said, we're pivoting and we're going to build that. And we thought, you know, what would it look like if we started building this framework? And we're like, well, maybe there would be like app scaffolds in the same way that like Twitter Bootstrap has scaffolds, and they come with components, and you can kind of build anything you want. And if you're a junior level developer, you would just basically choose a scaffold, choose your components, and then mod. But if you're a senior engineer, you could say, screw the scaffolds, I'm going root to the engine, and I'm gonna code whatever I want. And we said we would want to be able to do both ways, because that's the way we were using our engine. And we thought, what if we could just let developers build their own scaffolds? So if there was a developer saying, oh my God, I'm going to replicate the Twitter scaffold, or the Flipboard scaffold tomorrow, and then let everybody build Flipboard-ish apps. Or I'm going to replicate the Spotify cards sort of metaphor that you saw with Nathan, and then let everybody jam on that for a while, and have these sort of communities of developers working on these scaffolds so that we could all help each other. So we thought that would be super cool, and we had to make a big decision of, are we going to try to be a full stack solution, or do we want to just do one thing really, really well? And we as engineers always liked things where they just did the one thing well and let us choose the rest of our stack. So I think that's the direction that we decided to go. Do we plan on working with things like Backbone.js and Angular and all of your favorite MVCs? Yes. Use what you want. And then, will we have an open source license, and will we have a commercial license? We're figuring it out, but we definitely want to have an open source license so everybody can try this. We don't know quite what it looks like, and what the idea is we just popped our heads up a few weeks ago to announce that we're actually doing this change. And the thing is we want to build this framework with a community of developers. And so just a couple weeks ago, we said we're going to build this framework, and we've been working with our community to sort of like design what would be the coolest way to use this engine. If you want to get involved, our beta is open now. If you want to follow us on Twitter, I don't think we've tweeted yet, but we have a new Twitter account at @BeFamous. And there's only 3 of us in the company, so we need to hire a lot of people to build this thing out. So if anybody is really interested in actually joining this effort as being part of Famous, we would love to have help, because we're very tired people. That's the talk.